My name is Paul Marshall from Bing Bang Bong, and welcome to the Junkdojo workshop. Okay, so in this video we're going to be looking at how to make a standard template for a penny whistle fingering, which you can translate to any whistle of any size. There are two ways of doing this. One is to do it with the numbers, and for the numbers I'm using this book, Air Columns and Tone Holes, one of Bart Hopkins' books, or alternatively the other book is this one, which is Musical Instrument Design. This is the Bible. This is my my reference source. As you can see, it's been well thumbed, but this is the book. If you want to get a book, this is the one to get. Okay, so page 83 has this diagram which shows you where to put the holes in the flute. This is a standard penny whistle. This is a commercially made one, and as you can see there are 6 holes in it, and they play a standard scale. Okay, so we're going to seek to transfer that scale from this whistle onto any other sized whistle. Okay, and we're going to use a cheat for that. A template which will allow us to transfer it onto whistles not just of this length but of any length, and the holes will always be in relation. Now we know that the holes are placed according to a certain percentage of the overall length, and the overall length is a distance that goes from here, this sharp edge, down to what they call the distal end, the open end of the flute. Okay, so this is what we would call 100%, and the distance from here to the very last hole, this is 83%, this is 73%, this is 68%, this is 58%, this is 50%, and this is 43%. And those are all obviously as a proportion of this 100% length, which goes from here to here. So the easy way to do that is to take a simple elastic band, as you can see, lay it out, so it's just laid out in its natural flattened state alongside a ruler, and we're going to mark a point that we're going to call point 0, and this point here at the very end is the equivalent of where this sharp bit is. Okay, the equivalent of where this sharp bit is here. Now, because we're not going to make whistles which are any shorter than about 20 centimeters, and most of them will be substantially longer, we're going to take 20 as our basis, so that is our 100% is 20 centimeters or 200 millimeters. And if we know that the bottom hole, this hole here, is 83% of the way along from there to there, so 83% of 20 is 16.6. So we count down from here, from our fiddle mark, down to 16.6, and we make a mark on the elastic band. Our next one is 73%, so that's 14.6, and we mark that one on as well. Our next one is 68%, which is 13.6. Our next one is 15.8, which is 11.6. Pardon me, is 58%. Pardon me, 58%, which is 11.6. Our next one is 50%, which is going to be 10, and our next one is 43%, which is 8.6 centimeters. And we also mark our 20 centimeter mark, our 100% mark. So here we have our elastic band with a number of markings on it. As you can see, we have our fipple mark, and we go down and we have our first hole, second hole, third hole, fourth hole, fifth hole, bottom hole, and then the end of the whistle. So if I take this and I hold it up beside my standard whistle, put my fingernail right on this line here, and line that up with the edge of the sharp bit, get my other fingernail on this bottom line here, yeah, this bottom line here, and stretch it so as it matches the length of the whistle. You'll see now that the holes where I've marked them match roughly the length of the whistle. Okay, now there will be slight adjustments. You notice here, for example, on this commercial whistle, that this hole here is slightly smaller. and the reason for that is, as my template tells me, is that the hole should be lower down. The problem with that is the holes are very close together, and therefore you need to move the hole very slightly away just to give you a bit of extra room to get your fingers in. So, and by moving the hole away, then obviously you would make that into a higher note, so you need to compensate for that by making the hole slightly smaller. Okay, so as I said, fingernail on one end, fingernail on the other, stretch to the length of the whistle, and the holes should therefore be laid out for you. Okay, here's a whistle which I've just made, which is a PVC Kena, which is a South American whistle. This is made from some standard plumbing material, electrical conduit actually. And I take my marker, get my fingernail on the end of it, bring it to the end. In this case it has a notch style fipple. This is a U-shaped notch. So I take that right on the end there, right on the notch, stretch it down, find the last point from my last finger, stretch it across, and bingo, lo and behold, what do we have? It matches up pretty closely. Okay, so there you go. That's a quick way, a very quick way of transferring whistle lengths onto any kind of blank whistle into which you want to cut holes. Now this is for a standard penny whistle fingering. The other option that we could do is to go back to an actual whistle and not measure it, but we just take our elastic band, mark ourselves a start point, mark ourselves an end point, and when you have that, then go through and mark the holes on the elastic band to correspond with, mark the dots on the elastic band to correspond with the holes on the whistle. So for example, if I'm using a Native American flute, which has a different hole positioning than a penny whistle, all I have to do is to get my elastic band, stretch it across the length, mark where the holes are, then I can take that and transfer that to any size Native American flute that I'm making, whether it's a small one or a very, very large one. So that's how to make a template for marking the holes on a homemade whistle. Thank you. Thank you for joining. Thank you for watching Junk Dojo, or whatever the hell it is we're talking about. Bye.